Right, we have an object that's being thrown up from a cliff and it falls further than it was thrown from. We know the initial speed that it goes up with is 12 meters per second. The acceleration on its way up is going to be a negative 9.8, again because we're making positive v in this direction and it's slowing down, so the acceleration will be negative if the speed is positive. Speed's going to be 0 at the top. We also know that it's going to start 70 meters up and it's going to get to the ground, which we're going to call 0. One way to do this type of problem is to break it into up and down. So I'm going to do that first. So up, just looking at this part here, we know the initial speed, we know the acceleration, we know the final speed, so we can find the time. So solving for t, that's going to be v minus v0 over a. So that's going to be 0 minus 12 over negative 9.8 is going to give us 1.2 seconds. Now in order to do down, we need to know how far it falls. But in order to know how far it falls, we need to know the distance that it falls. So that's actually the next thing that I'm going to find. That's part C. So our y value is going to be equal to v squared minus v0 squared over 2a. And that comes from y, our 2ay is equal to v squared minus v0 squared, and then rearranging that equation. So this is going to be equal to 0 squared minus 12 squared over 2 times negative 9.8, being really careful with order of operations, and then that's going to be a distance of 7 meters. But remember that that's above the 70 that we were, so we're going to add 70 meters to that, and that gives us 77 meters. So that's actually the maximum height that we get to. So now let's take a look at down. For the trip down, I can make positive go downwards. Our initial speed heading down is going to be 0. The acceleration going down, if that's a positive speed headed down, then acceleration is a positive 9.8 meters per second squared. And my y value is going to be 77 meters. And it's going to start from 0. So it's a different way of looking at things. So then y is equal to y0 plus v0t plus 1/2 at squared. That 0, that goes away. We can solve for t and get 2y over a. That gives us 2 times 77 divided by 9.8. And that's going to give us a time of 4 seconds. To get the total time then, which is what they asked us to find, that's going to be the t up plus the t down, which is equal to 1.2 plus 4, which is 5.2 seconds. All right, now the other way you can do this is using quadratic formula. We have this equation, y is equal to y0 plus v0t plus 1/2 at squared. Our y is 0. We end up at the ground. Our y0 is 70. Our v0 is 12. And our a is negative 9.8. So rewriting that. Oops. All right, and we've got our quadratic. This is our a, b, and c term. So t is equal to negative b plus or minus b squared, or square root of b squared minus 4ac. That's going to give us negative 12 plus or minus 12 squared minus 4 minus 4.9 times 70 divided by 2 times a. When all is said and done, you're going to end up with t equal to 5.2 seconds. and negative 2.8 seconds. The negative 2.8 seconds corresponds to where it would be inside the ground, inside the cliff, at the ground level, which obviously we can't do that, so we reject that solution, and we end up with 5.2 seconds, the same as we got here.